a river of white pours into a 1,000-gallon steel tank. It looks exactly like cream. It is not cream. This is a Cool Whip factory. Every day, this single facility pumps out enough whip topping to fill a swimming pool. And the reason they call it whip topping instead of whipped cream, that's a story the label doesn't want to tell you. But first, let's watch how this stuff actually gets made. The trucks pull up to the loading dock carrying ingredients you would never expect. No tankers of fresh cream, no dairy deliveries at all. Instead, you see drums of hydrogenated vegetable oil, pallets of corn syrup, bags of powdered emulsifiers with names you can't pronounce. That's what Cool Whip starts as, oil and water. Workers unload everything into a climate-controlled warehouse. The vegetable oil arrives semi-solid, like soft margarine. It's a blend of coconut and palm kernel oils that have been hydrogenated. That means hydrogen gas was forced into the oil under pressure. The process turns liquid oil solid at room temperature. Think of it like turning cooking oil into something closer to butter. Except it's not butter, and it never will be. The corn syrup arrives in massive drums. High fructose corn syrup and regular corn syrup. Both serve as sweeteners, but they also help the final product stay smooth after freezing. Then there are the specialty ingredients. Sodium caseinate, a protein isolated from milk. Polysorbate 60, sorbitan monosterate, xanthan gum, guar gum. So why does this lineup matter? These are the ingredients that make oil and water do something they naturally refuse to do, stay mixed together. Everything starts in a blending tank. Workers pump in filtered water first. It fills about 40% of the tank. Then the hydrogenated vegetable oil gets heated until it melts into a clear liquid. It's pumped into the same tank. Here's the thing, oil and water hate each other. Pour oil into water at home and watch what happens. The oil floats to the top every single time. Your salad dressing separates in the fridge for exactly this reason. So how do you force them together? You cheat. Workers add the emulsifiers. Polysorbate 60 and sorbitan monosterate go in first. These molecules have a split personality. One end loves water, the other end loves oil. They wedge themselves between the oil and water molecules. Think of them as tiny molecular peacemakers. Each one grabs oil with one hand and water with the other. That's genuinely brilliant chemistry happening inside a food factory. The corn syrups go in next, then sodium caseinate, that milk-derived protein. It acts as a secondary emulsifier. It also gives the mixture a slightly creamy flavor. A massive paddle agitator spins through the tank. It blends everything at controlled speed for about 15 minutes. The result looks like thin, slightly yellowish milk. Not appetizing yet, not even close. The blended base gets pumped into a homogenizer. This machine is about to do something violent to this liquid. It forces the mixture through a tiny gap at extreme pressure. We're talking 3,000 pounds per square inch. That's roughly the water pressure 2 miles deep in the ocean. Every fat globule in the mix gets shattered into microscopic droplets. These droplets are smaller than a red blood cell. Why does this matter? Smaller fat droplets mean a smoother texture. They also stay suspended instead of floating to the top. Before homogenization, the mix is grainy and unstable. After, it's silky, uniform. Every single drop is identical to the next. Here's an everyday comparison for you. Homogenization is why store-bought milk doesn't separate. Same principle, same physics, just cranked up to industrial scale. The homogenized base then passes through a pasteurizer. It hits 165 degrees Fahrenheit for exactly 15 seconds. This kills any bacteria and extends shelf life. Then it's rapidly cooled back down to around 40 degrees. The base flows into a holding tank to rest. This resting period matters. It gives the emulsifiers time to fully coat every fat droplet. Think of it like letting paint dry between coats. Rush it and the final product falls apart. The base sits for 4 to 12 hours. Patient, quiet. When it comes out, it's thick, stable, ready for what comes next. But before we get to the step that turns this base into actual Cool Whip, we need to talk about what's really in this tank and what's not. Now stop. Look at the label on a tub of Cool Whip. It doesn't say whipped cream. It says whip topping. That is not a branding choice. It is a legal requirement. The FDA has strict rules about what can be called whipped cream. Real whipped cream must contain cream from actual cow's milk. That's the standard, no exceptions. Cool Whip contains 0 dairy cream. Let that sit for a second. The most famous whipped cream in America has never actually contained cream. Look at the ingredient list side by side with real whipped cream. Real whipped cream has 2 ingredients: cream, sugar, maybe vanilla. That's it. Cool Whip's first ingredient is water. Second is hydrogenated vegetable oil, then high fructose corn syrup, then corn syrup. Skim milk appears further down. Light cream shows up near the very bottom. The amount is so small it changes absolutely nothing about the classification. The FDA classifies Cool Whip as an imitation whipped topping, not whipped cream, not even a cream substitute, an imitation. That word, imitation, is specific. It means a product resembles a traditional food, but it fails to meet the legal standard of identity for that food. It's the same classification the FDA gives imitation crab meat. Looks like crab, tastes somewhat like crab, is not crab. Cool Whip looks like whipped cream. It sits next to whipped cream in the freezer aisle. It gets dolloped on pies and strawberries just like whipped cream. But legally, scientifically, and compositionally, it is not whipped cream. And here's the part that really gets you. Kraft has never publicly advertised this fact. Not once. They've never run a campaign explaining that their product isn't real cream. They don't hide it. It's printed right there on every tub. But they've never once highlighted it. Watch any Cool Whip commercial ever made. Listen carefully to every word. They say whipped topping. They say Cool Whip. They never say whipped cream. Every syllable in every ad is chosen to stay on the right side of FDA regulations. Millions of people have spooned Cool Whip on Thanksgiving pies for decades. Many of them genuinely believed it was whipped cream. It never was. Not in any formula. Not in any year. The entire product is engineered to mimic real whipped cream. The taste, the texture, the appearance, all of it built from ingredients that are fundamentally not cream. And honestly, that engineering is remarkable. Making oil and water feel like whipped cream in your mouth is one of the hardest tricks in food science. Which brings us back to the factory floor, because the next step is where that trick actually happens. This is where Cool Whip becomes Cool Whip. The chilled homogenized base gets pumped into a continuous aerator. This machine does something deceptively simple. It injects gas directly into the liquid. Nitrogen or nitrous oxide gets forced into the base under pressure. Simultaneously, the machine whips the mixture at high speed. Tiny gas bubbles get trapped inside the emulsified fat. Each bubble sits inside a thin shell of fat and emulsifier. That shell keeps it from popping. Now here's a stat that might break your brain. The volume of the mixture doubles. Sometimes it nearly triples. You start with 1 gallon of liquid base and you end with almost 3 gallons of finished product. 2/3 of every tub of Cool Whip is just trapped air. You're basically buying air held together by oil and water. This ratio is called overrun, and it determines how light and fluffy the product feels. Too little air and it's dense, like pudding. Too much and it goes foamy and collapses on your spoon. Cool Whip targets a precise overrun percentage. The factory monitors it in real time. Sensors measure the density of the aerated mix every few seconds. If the reading drifts, the machine adjusts gas flow instantly. When the mixture exits the aerator, the texture is unmistakable, light, fluffy. It holds a peak when you scoop it. It looks exactly like freshly whipped cream, except you already know what it actually is. The aerated product flows directly to the filling line. No waiting, no holding tanks. Speed is everything here. The mixture needs to stay cold and aerated. Any delay and the bubbles start collapsing. Flat Cool Whip is ruined Cool Whip. Filling nozzles deposit a precise amount into each plastic tub. The machines run fast, dozens of tubs per minute on a single line. Each tub gets filled to a target weight, not volume, weight, because air content can vary slightly. Weight is the only reliable measurement. Lids snap on automatically. Then the sealed tubs enter a blast freezer. This is not your kitchen freezer, not even close. Blast freezers hit -20 to -40 degrees Fahrenheit in under an hour. Some facilities push it even faster. Why the rush? Because slow freezing creates large ice crystals. Large crystals are jagged. They puncture the foam structure from the inside. They make Cool Whip grainy and icy when it thaws. Fast freezing creates tiny ice crystals. Tiny crystals sit quietly between the air bubbles. They preserve that smooth, creamy texture you expect when you peel the lid back. The difference between good Cool Whip and bad Cool Whip comes down to how fast you freeze it. That's it. The frozen tubs exit the blast freezer on conveyors, rock solid. You could stack them floor to ceiling without denting a single one. Before any batch ships, quality control pulls random samples off the line.
Technicians test overrun percentage, they check pH levels, they run microbial counts. Then they do something surprisingly low-tech. They taste it. Trained sensory panelists evaluate every single batch.
Flavor, sweetness, mouthfeel, the way it dissolves on your tongue. If anything is off, even by a fraction, the batch gets flagged. In a product this carefully engineered, consistency isn't optional. It's the entire point. People expect Cool Whip to taste identical every time they buy it. One bad batch and a customer switches brands, possibly forever. Tubs get packed into retail cases. Cases get stacked onto pallets by robotic arms. Pallets roll straight into refrigerated trailers. Those trailers maintain a constant below-zero temperature from factory to distribution center to store. The cold chain never breaks. One temperature spike during transit could destroy the texture permanently. And here's the thing, consumers would notice. Even if they couldn't explain the science, they'd feel something was wrong. The first spoonful would tell them. Let's zoom out and talk scale. Cool Whip generates over $1 billion in revenue every single year. During Thanksgiving week alone, Americans buy roughly 60 million tubs. 60 million in 7 days for a product classified as an imitation. The factory runs around the clock during peak season. Multiple production lines, hundreds of workers per shift, trucks leaving every hour. Every year, the operation burns through millions of pounds of hydrogenated vegetable oil, millions of gallons of corn syrup, enough water to fill hundreds of tanker trucks. All of it gets transformed into something that looks and tastes like whipped cream, through chemistry, through engineering, through a process so seamless that most people never think to question what's in the tub. That might be the most impressive part of the whole operation. It's wild that the most iconic whip topping in America was never real cream and almost nobody noticed for decades. Now that you know Cool Whip is legally an imitation, does that change how you feel about putting it on your pie? Tell me in the comments. If you made it this far, hit subscribe. We'll see you in the next one.